Hi there, this is Professor Barber. I'm providing for you worked exercises of problems similar to some of the problems of your homework assignment. Example, the product of two odd integers is an odd integer. First, let's note that it is not sufficient to select a few specific odd integers, multiply them, and then decide that the results of a few examples is sufficient to prove true for the entire set of integers. With that said, a proof requires that you show the statement true for every product of any two odd integers. So let's begin. To write a proof, we begin by writing PF to indicate that's what we're doing. And then we're going to take two arbitrary odd integers. So I'm going to say let A and B be odd integers. Okay? So we'll write we'll say that there exists an integer R such that A is equal to 2 times R plus 1. That makes it an odd number. And an integer, I need another letter, T, such that B is equal to 2T plus 1. Then let's see what happens. Then the product of A times B is equal to, and A is expressed as 2 times R plus 1. B is expressed as 2 times T plus 1. We can multiply this, so we get 4RT plus 2T plus 2R plus 1. This actually doesn't quite show that we have an odd number, but let's simplify a little bit. We can factor out a 2 from the first three terms. So now we get 2 times 2RT plus T plus R plus 1. Okay? Let's note that what's in the parentheses, 2RT plus T plus R, is an integer. And so we've actually shown that you've got A times B is equal to 2 times some integer plus 1 is an odd integer as required. Now, when you finish a proof, you have to indicate that you're done. Okay? Typically, we write QED, which means you've proven what you were setting out to prove, or you can also write a little square, and that also means that you have proven what you have set out to prove. Example, if A equals the set consisting of J, K, and M, find P of A. P of A is the power set. You recall that the power set is the set that contains all subsets of A. So when we begin this work, we have to determine, or I like to determine, how many elements are in the power set just to make sure I get them all. Okay? The possibility for each element is it's either in the set or it's not in the set. So the element J is either in a subset or it is not. You've got two choices for that. So J can either be in the set or not in the set. Similarly for K. K could be in the subset or not in the set, so you've got two choices. It's binary, and the last element of set A is M, and that also means it could either be in a subset or not in a subset. When we solve this, we get 2 cubed, and what this tells us is that the cardinality of the power set, so let's just go ahead and denote that the cardinality of the power set consists of 8 elements. However, we weren't asked to find the number of elements we were asked to find the power set. And so what we have to do is make sure we list them all, and you know that you're done when you get 8 of them. So let's begin. All right. P of A equals, remember sets have to have the curly brackets, and I'm going to start with the smallest number possible in the subset and then continually increase. So the smallest subset possible is the empty set, the set that contains no elements. And then we'll start increasing, and so we begin. The J is in the set, so we have a subset consisting of that, and let's do that for each of the 3 elements of the set A. So J could be a subset of its own, so can K, and just as well can M. Now, the next thing is we need to be methodical because we've got to get subsets that have 2 elements in it. Want to make sure you don't repeat any, but then you also don't forget any either. So I usually start with the first element and move to the right. So consisting of 2 elements, the subset could have J and K. Then skipping the K, I can also have J and M, and then let's do one where J's not in a subset, so we would have one that is K and M. So let me count. I've got 1, 2, 3, 4, 5, 6, 7, but I'm supposed to have 8. Oh, we could have a subset that consists of the entire set. So we will list J, K, and M, and don't forget the final bracket, okay? Because you need the big brackets on the outside to denote the power set, and then the little ones for each of the subsets within the power set. And so I've got 1, 2, 3, 4, 5, 6, 7, 8 elements in the power set. Example, draw Venn diagrams for A. I've got the negation of A intersect B. Let's note that the line above A intersect B means negation. I'm going to do this in 2 steps. So I'm going to start with finding A intersect B. Intersect means what is common, and so that's the football looking shape that is common to both A and B. Now, the next step is going to be for me to shade in everything that does not include what was previously shaded. So, I'm going to take the Venn diagram we just did. The bar over it says I want to shade everything that's not or was not previously shaded. It is also sometimes called a complement. C-O-M-P-L-E-M-E-N-T. It's the completer. It makes the whole Venn diagram. So in this instance, the complement or the negation of A intersect B is the Venn diagram portion that was not shaded for A intersect B. And just notice that if you were to superimpose those 2 Venn diagrams on top of each other, you would complete the entire rectangle. It completes it. Draw a Venn diagram for, and we have in parentheses A union B complement intersect C complement. We still have the same order of operation, so we begin from within the parentheses, and let's begin with the first one, which is B complement. That means shade everything that is not B. So let's carefully shade everything that is not B. Let's build on that to do A union not B. So I'm going to progress to the right, and I want to find the Venn diagram for A union not B. Union means everything that's in A or everything that's in not B. So the only part that was not previously shaded was this one portion of A, But we need to union that is, put it together with everything else that was previously shaded. So let's see. We're just going to include the parts of A that were in B previously not included. Now let's progress on over and try to find the intersection of not C. So looking at not C, let's shade everything that is the negation of C. Now, the final step is to do the A union not B intersect C. So for the last one, I'll do A union not B intersect C. That means I want to look at these two Venn diagrams and get the points where there is blue and the pink, where it is shaded together because of the intersection symbol. We notice that the only part that is common is the intersection of A and B, not including the C. Now let's continue to look. Parts of C in entirety are not shaded, same for the B. So the remaining parts where there is pink and blue together, trying to shade it, and so we get to see which part is not shaded, and this is the final Venn diagram.